Elasticity of demand. We introduced several new functions here in this section. The first one is the demand function. Demand function. We use D, or you can say D of X, or some people use small q. We have the elasticity of demand, which is E, and it's defined as E of X as negative X times the demand function at X over derivative over D of X, where X here is the price. X is the price. So that's how we calculate the elasticity of demand. So most likely the demand function will be given, and all we have to do is find the elasticity of demand by finding the derivative of the demand function times the price divided by the demand function. And to see an example on this, internet rentals affect clicks video in such a way that the demand for rentals of its DVD changes to Q equals D of X 30 minus 5X. That's the demand function. Part A, find the quantity demanded when the price is $2 per rental, $3 per rental, and $5 per rental. So they just give you the price and they want you to find the demand. So they want you to find D at $2, D at $3, D at $5. So all we have to do is straight substitution into the given demand function, 30 minus 5x, so minus 5 times 2, 30 minus 5 times 3, and 30 minus 5 times 5. That would give us 30 minus 10, which is 20, 30 minus 15, 15, and 30 minus 25, 5. Part B, find the elasticity of demand. As a function of X. We need to find the elasticity of demand. So we defined the elasticity of demand as negative X times derivative of D. So the first thing I'm gonna rewrite the function, find its derivative of 30 is 0 minus 5, then E of X equals negative X times D prime of X over D of X. Negative X times negative 5 over the function itself. So that gives us 5x over 30 minus 5x. Find the elasticity at x equals 2, 3, and 5. So we found the elasticity E of x. We have a function, so we need to find E of 2. Just substitute into the box the function E 5 times 2 over 30 minus 5 times 2. That's 10 over 20, which is 1/2. We need to find E at 3. 5 times 3 divided by 30 minus 5 times 3, which is 15 over 15. That's exactly 1. And the last one, E of 5. 5 times 5 divided by 30 minus 5 times 5. 25 over 5 is 5. Part D. Find the value of x for which E of x equals 1. E of x equals 1. So we need to find the price that would make E of x 1. Well, we know it is here. See, look, the E of x is 1 when x equals 3. But let's see how we find that out. So E of x is 1. We found E of x was 5x over 30 minus 5x is 1. So then cross multiply. 5x equals 30 minus 5x. Add 5x to both sides and divide by 10. See, we get 3. Find the total revenue function R of x, which is defined as x times d of x. So it's a direct substitution. X times d is 30 minus 5x. And all we have to do, multiply that out. 30x minus 5x squared. Find the price x at which the total revenue is a maximum. So we found the function for the revenue. So maximum or minimum, that reminds me of derivative equal to 0. So we have R of x, 30x minus 5x squared. So we find R prime of x, which is 30 minus 10x. If we set that equal to 0, we can add 10x to both sides, divide by 10. This is x. So find the price, so that's the price, at which the revenue is a maximum. So the revenue will be maximized for this specific demand function when x equals 3. Well, remember, when you find R prime and set it equals 0, that could mean min or max, we don't know. So is this min or max? Well, to check that out, we find the second derivative. That's called the second derivative test. Second derivative of this is 0 minus 10, negative 10. So it's definitely less than 0. Less than 0 means it concaves down. Concaving down means there's a maximum. So that confirms it's a maximum. And that's what we're looking for. Now, quick thing to know, when E of x, the elasticity of demand at the price x, bigger than 1, then the total revenue decreases. And we say D, the demand, is elastic. When E of x is less than 1, then the total revenue increases. And in this case, D is inelastic. When E of x is 1, then the total revenue is at its maximum. Good to know. So I can graph this. This is x, this is the demand, d of x. So the price and d of x. So the way this works, this is, assume this is x and this is a function d of x. So when we project this up, that's when e of x is 1. This to the right side, that's when e of x is bigger than 1. So that's dx is elastic. And this is when e of x is less than 1, inelastic. That's a quick representation of what I just spoke about. Also, I can represent the total revenue. So this is the price x on the x-axis, and this is the total revenue. So the total revenue, let's say, goes this way. So at some point, it will be maximized at that one, at that point there. And these two graphs can be put into one graph, just one graph. We can represent it as one graph. One graph like so. This is the revenue, total revenue, and this was the function, the demand function. So this point, at that point, that's when e of x equals 1. So e of x equals 1 gives us the maximum revenue. That's the maximum revenue. And that's why we can represent both of them on one graph. That's the revenue, and the other one is the demand. So again, as a quick review, we learned about elasticity of demand, the demand function, how to find min and max, when is d of x elastic and inelastic based on the e of x, if it's bigger than 1, less than 1. And if it's at 1, that gives us the maximum revenue. We apply this in businesses.